Okay, so we just got done talking about all kinds of mutations. Mutations change genes, which change amino acids, which change proteins, which causes people to have the genetic disorders. A lot of times people with genetic disorders or family members have a genetic disorder, or if they think they do, they'll end up going to see a genetic counselor. Genetic counselors look at karyotypes. They use Punnett squares and pedigree charts to discuss genetic issues with a family. And they try to predict if this disease is an autosomal dominant disease, is it autosomal recessive, is it X-linked, is it due to incomplete dominance, and then discuss options for the family and possibly discuss how you can treat the symptoms of the disease. Remember, you can't cure genetic diseases because we can't change your genes. Now, a karyotype is just a picture of your chromosomes, and they can look at that to see if a chromosome's too big, too small, if it's missing, if there's extra. And on the next slide, I have a picture of a karyotype. Okay, so there's a karyotype. There's 2 of every chromosome. Chromosome 1, chromosome 2. Remember, you get one from mom, you get one from dad, all the way through till the sex chromosomes, which you get one from mom and you get one from dad. And then here's a picture, or we're going to be talking about pedigree charts. So genetic counselors also use pedigree charts, and we're going to practice making a pedigree chart of your family later on. A pedigree is a visual showing the pattern of inheritance for a trait. It's kind of like a family tree for your genes or a family tree for a certain characteristic. So when you make a pedigree chart, the males are always square and the females are always circled. And if you have someone with the disorder, or if you're talking about a particular trait, you shade it in, so you color it in, and the unaffected ones, you don't color in, you leave them blank. And if it's something called a carrier, they're halfway shaded in. And a carrier is somebody that carries the gene, but shows no sign of that genetic disease. For example, if you are heterozygous, big T, little t, and let's say that little t is messed up. That person's not going to have any symptoms for that messed up gene because they have that big T, which can overpower the little t, so it's like it's not even there. But they're considered carriers because they carry the gene and they could give that gene to their children. So this is what a pedigree chart actually looks like. Again, the squares are male and the circles are female. A line across means it's from mother to father, and lines down are to the siblings. Okay, now we're going to start talking about some specific genetic disorders and hopefully give you ideas on what you want to do your project on later next week. Okay, autosomal chromosome number abnormalities. This is an abnormality with an autosomal chromosome dealing with a number. Remember, you have 46 total chromosomes. 44 are your autosomal chromosomes, 2 are your sex chromosomes. So we're not talking about the X and Y's, we're talking about all the other chromosomes. And it's a number abnormality. So these people don't have 46, they usually have 47 or 45. So one example is Down syndrome. The chromosome 21 does not separate correctly, so they actually have 3 21 chromosomes. This is also called trisomy 21, tri meaning 3. They will have 47 chromosomes instead of the 46. Children with Down syndrome develop slower, may have heart and stomach illnesses, and they have varying degree of intelligence. Some of them have to live with a parent, some of them can live on their own. So again, these people have 45 autosomal chromosomes instead of the 44, and their sex chromosomes are fine. They're still either XX or XY. There's nothing wrong there. It's just they have an extra 21st chromosome, which gives them the 47 chromosomes. Now remember, with any autosomal chromosome number disorder, it's due to non-disjunction or an extra or missing chromosome. It's not just a piece that's missing, it's the whole chromosome is missing, or in this case, a whole extra chromosome. So it's not just one extra gene, you have thousands of extra genes with these autosomal chromosome number abnormalities. There are other ones out there, like the Pate syndrome and Edwards syndrome, but the most common one is Down syndrome. And there is a picture of their chromosomes. again, numbered 1 all the way through the sex chromosomes, and you can see that 21st chromosome, they have 3 there instead of just the 2. Okay, now sometimes non-disjunction takes place with the sex chromosome, the X or the Y. So you have sex chromosome number abnormalities, an abnormality or disorder of the number of the sex chromosomes. Again, due to non-disjunction, sperm after non-disjunction will maybe have 2 X's, 2 Y's, or be X and Y, or maybe no sex chromosome at all will be in the sex cell. Remember, a sperm should just have 1 X or 1 Y. Sperm get half of the normal. So in a sperm, you're 22XX, 22YY, 22XY, or just 22. A normal sperm is 22X or 22Y. Egg after non-disjunction is going to have 2 X's or no X's at all. And if you remember, an egg should only have 1 X. So egg after non-disjunction is 22XX or just 22, and the normal is 22X. So if you have a normal sperm and a normal egg hooking up, that's where you get your, say, 44XX or 44XY, which makes your 46 chromosomes. But let's say we have a sperm that is 22XX, and it hooks up with a normal egg, which is 22X, then you have somebody who's 44XXX. Okay, so it's just the number of the sex chromosomes is messed up, and we're going to talk about a few disorders that deal with that. Okay, there's something called Klinefelter syndrome. With Klinefelter syndrome, these men are XXY, usually that's how they end up. They have to be men because of that Y chromosome, and they will have sterility problems, meaning they can't have babies. So that's Klinefelter syndrome. Okay. Then there is XYY syndrome. They have normal male traits. They're often tall, possibly thin. And at one time, being an XYY male, these men were associated with having antisocial and behavioral problems because they thought they produced more testosterone than a normal male. But after tons of studies have been done, nothing has ever become of that. So XYY male, sometimes that's called Jacob syndrome. And then we have Turner syndrome, which is just X. It is a female, but they're just X. They're missing a sex chromosome. Their sex organs don't mature properly. They can't have babies. And oftentimes they're very short. And sometimes they'll have heart problems and have to have heart surgery. And then there may be some mental disability there also. Then we have the meta-females, which is also called trisomy X, because tri means 3. So these are the XXX females. Little or no visible differences. They may be taller than normal, may have some learning disabilities, and possibly limited fertility, meaning a hard time having children. And there's just a little cartoon, and it says, your case would make a great medical journal article, but frankly, the National Enquirer pays more.